is the location of that point. We mark asterisk. Then for the next value of, we now go back to the graph. The next value of x is 4. The next value of y is 0. So since the 4 is now on the line of 0 is on the line of origin of the vertical axis, we mark it at that point 4. Then the next value for s is 5, and the next value of y is minus 15 on the table. Then we now go to the graph and locate where 5 is, which is for the s axis or the horizontal axis. Then for the y value, which is minus 15, we is now pointing downwards. Then go to the negative value of minus 15 and trace it. Where minus 15 and 5 intercept is the location of that point. We now mark asterisk. Then the next value is 6 for x in the table, and for y is minus 3. Where the two, now trace the value of 6 downwards and trace the value of minus 36 downwards at the negative side of the y axis. Where the two meet is the and intercept is the location of that point. You mark asterisk. Then from the tabulation of y equals to 5x minus 2, we draw a straight line. Since it's a straight line graph, the table will now be, the graph will now be at the point. The first value for x is 2 on the table, and y is 0. So at the point where x is plus 2, y is 0. So at the point there, that is at 2, you mark asterisk. When x is 0, y is minus 10. So when s is 0, y is minus 10. So at the point 10 on the vertical axis of y, on negative y axis, we mark asterisk. That's the location of that point. Then for the last value of s, as is on the second table, we have s to be 6, then and the y to be 20. Then you locate the points where the s is 6 and y is 20. Where the two meet, you mark our asterisk. That's the location of that point. We draw a straight line for this. And now for the first one, we draw a curve using a French curve or a broomstick or any material that is flexible enough for you to make the curves of the graph. From the graph, we are told to find the roots of the equation 3s bracket 4 minus s is equals to 0. To get the root of the equation, we now equate the equation 3s minus 4 minus x equal to 0 and solve for x. If we do our factorization very well, we now find that from the graph that s is equals to 0 over 3 is 0, or s is equals to 4. When 4 crosses equality sign to cross over, it will become plus. The value of s where the graph got the s, this is the value of s where the graph got the x-axis. Then we have to write down the maximum value of y equals to 3s bracket 4 minus s within the given range. So the maximum value, that is where the at the peak of the curve is now our maximum value traced to the vertical axis, which is 12. Then the maximum value of y is 12. Then D, we are asked to deduce the root of the equation 3x bracket 4 minus x equals to 5 bracket x minus 2. Then if you now find the point of intersection of the line on the graph, meaning the straight line graph where they intercept with the curve on the line, s is equals to minus 1 or 3.3. The point of intersection of the line and the graph of the 3s bracket 4 minus 4 minus x. Question 6. I form a table of value for the relation y equals to s squared minus 4 from s equals to minus 3 to s equals to plus 3 at an interval of 1 unit. Use your table to draw the graph of the relation From the graph, find out the roots x squared minus 4 equals to 0. Answer. First of all, we tabulate the value of y equals to s squared minus 4 from s equals to minus 3 to s equals to plus 3. Therefore, s from the range from which s is minus 3 to s equals to plus 3 is minus 3, minus 2, minus 1, 0, 1, 2, and 3. Then, since we are looking for y, then we equals to s squared minus 4. We now find s squared. So whenever we see s, we replace it with the values of x. Therefore, we now have minus 3 squared is 9, minus 2 squared is 4, minus 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Then minus 4 is there, it does not have any unknown value. Then we have minus 4 as a constant, which is minus 4 minus 4 minus 4. Then, since to get y, the unknown, we minus s squared minus 4. Therefore, along the first column, we have 9 for s squared and 4 minus 4 for the, we now have 9 minus 4, which gives us 5. Then for the second column, we have for s squared 4 minus 4, which is 0. Then for the third column, we have for s squared 1 minus 4, which is minus 3. For third column, we have for s 0 minus 4 minus 4, which is minus 4. For the fifth column, we have 1 for s squared minus 4, which is 4. Then for the sixth column, we have 1 minus for s squared minus 4 to give us minus 3. For seventh column, we have 4 for s minus 4, which is 0. For the last column, we have 9 for s squared minus 4 to give us 5. And we are now told to use a scale 2 cm to represent 1 unit on the x-axis and 2 cm to represent 2 units on the y-axis.